Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள் கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yeah, good morning students. Today I am going to explain the topic chemical bonding. I already given chemical bonding videos, hybridization, VSEPR, Lewis dot structures, and you can search in YouTube and Vari Medical Academy. It will be available. Today topic is chemical bonding. Some topics are we are missing. Right, chemical bonding. Chemical bonding. Now NEET exam, it will be asking question every year. 3 to 4 questions are asking based on dipole moment, based on shape of the molecules, hybridization, and another one is Lewis dot structures. And one time they are asking bond order. Last year 2022 they are asking question bond order, based on bond order they are asking questions. And today topic is chemical bonding. Now what is a chemical bond? Generally chemical bond means atoms are more energetic. More energetic means they release energy, they involved in bonding. Atoms are more energetic, they release energy after they involved in bonding, means they form molecules. Okay, the reason of chemical bonding means to attain stability, to attain the stability, because atoms are more energetic. More energetic means less stable after they release energy involved in bonding. First one is to attain stability, to maintain octet rule, to maintain or obey, to maintain octet rule. What is octet rule? Every atom must contain 8 electrons in outermost energy shell, outermost orbit or outermost orbital. That is called octet rule. Every atom must contain 8 electrons in outermost energy level. That is called octet rule. Means another one means the atom to try to maintain noble gas configuration. Noble gas configuration. Why noble gas configuration? Because noble gases are stable. Already they filled 8 electrons in outermost energy level, and because of this reason the atoms are involved in bonding to attain the stability. Next one is to maintain octet rule. To maintain octet rule means the atoms are losing electrons or sharing electrons or gaining electrons. They have to maintain 8 electrons in outermost energy level. That is called octet rule. Next reason is noble gas configuration. Every atom they try to maintain noble gas configuration, because noble gases are inert gases. They are not involved in any reactions, especially xenon only reaction with fluorine and oxygen. Understand? Here is to attain the stability, to maintain octet rule, noble gas configuration. That is a chemical bonding reason. Next one is, what is chemical bonding means? The attractive force which holds the two or more constituent atoms. The attractive force, write down, the attractive force attractive, the attractive force which holds two or more constituent atoms, that is called chemical bond. The attractive force which the attractive force which holds the two or more constituent atoms or two or oppositely charged different chemical species in a chemical bond. Now in chemical bond there is a equilibrium between attractive forces and repulsive forces exist. In a chemical bond there is a attractive forces and repulsive forces are in equilibrium. Now write attractive and repulsive forces are exist. Equilibrium means the maintain forward and backward is same. In the case of equilibrium, forward direction and backward reaction, there is a equilibrium. Next, attractive and repulsive forces are exist in equilibrium, This is called chemical bond. The attractive force which holds the two or more constituent atoms, attractive and repulsive forces are exist in equilibrium. Now we can take two nucleus, A nucleus and B nucleus. What are the attractive forces and repulsive forces are present? Alright, the students, here I am taking A nucleus, here is A nucleus I am taking, and here is electrons are present, na? Electron, because electrons are revolving around the nucleus in circular orbit. Here is A nucleus, this is the atom, A nucleus is present, here is electron of A, here also B nucleus is present, and now here also electrons are present. What is the, I already explained, the attractive force and repulsive forces are equilibrium. Now nucleus of A, this one is I am writing Na, nucleus of A. Next one is Nb, nucleus of B. Next one is electron of A and electron of B. Here two nucleus I am taking is the atom. Atom consists center positive part, that is called nucleus. In nucleus protons and neutrons are present. Electrons are revolving around the nucleus in circular orbit. That is we can discuss in Bohr's theory. Here is nucleus of A attracting electron of B. Here is nucleus of A attracting electron of B. Here nucleus of B attracting electron of A. There is equilibrium. Attractive forces and repulsive forces are in equilibrium. Is actually VBT, valence bond theory, but we are first explain how attractive forces and repulsive forces. Now I am taking here is nucleus of A and nucleus of B. This one is nucleus of B, this one is nucleus of A. This is electron of A, this is electron of B. Now nucleus of A attracting electron of B. Next, nucleus of B attracting electron of A. What are the repulsive forces? Repulsive forces, I am writing repulsive forces. Repulsive forces. What are the repulsive forces? Means similar charges are repelling each other. Already everyone knows this one. Nucleus of A and nucleus of B repelling each other. Electron of A and electron of B is repulsions. Because similar charges, positive, positive, negative, negative, repulsion. Positive, negative means attraction. Now, what are the repulsive forces? Na and B. Nucleus of A, nucleus of B, repulsion, and electron of A, electron B, repulsion. Next, what are the attractive forces? What are the attractive forces? The attractive forces are nucleus of A attracting electron of B. Nucleus of A attracting electron of B. Next one, nucleus of B attracting electron of A. Because this is positive, this is negative, there is a attraction is present. Here is, these are the repulsive forces and these are the attractive forces that is present in chemical bond. Why atoms are involved in bonding? The atoms are more energetic. Energetic means they are highly unstable. They try to form the molecules. How to form? They release energy. They release energy. Releasing energy means exothermic. What is the name? Releasing energy. Exothermic. Always chemical bond is exothermic, not endothermic, not energy absorbing, energy releasing. Now we can write the students. Now you can do the write the notes and repulsive forces and attractive forces. What are the attractive forces and repulsive forces exist in a chemical bond? Will erase? Okay, very good. Next one is there is a, you can plot the diagram one. Now I am taking, here is potential energy. Potential energy means energy increases. Now internuclear distance, this one is internuclear distance. Internuclear distance. What is the name, students? Internuclear distance means the bond length. We can write R. Internuclear distance is R. Energy, this is the potential energy. Now I am taking, here is a negative. Negative means attractive forces is present. Attractive, this reason, and here is plus attractive. This is the repulsive. Sorry, this is a repulsive. Repulsive because it, here I am taking two hydrogen atoms. This is one hydrogen atom, here is another hydrogen atom. Because these hydrogen atoms are highly energetic. Highly energetic means they are not stable. If you take a old man and a young person, which one is more stable? Old person is more stable because less energy. He already tired. And here also hydrogen atoms are the more energetic. They release energy. Here is more potential energy. This reason more potential energy. If you write, I am writing this one. Draw. Here is now this distance. This distance is bond energy. Bond energy. Now this distance is bond length. Bond length. What is bond length? The half of the distance between nuclei of two atoms. What is bond energy? Bond energy means the amount of energy required to break the bond. That is called bond energy. Already we can know bond dissociation energy. Bond dissociation energy means bond formation energy we cannot use. Bond formation means releasing energy we cannot calculate. Only we are giving energy only calculate. That's why bond energy means the amount of energy required to break the bond. That is called bond energy, bond dissociation energy. Here two hydrogen atoms are there. Here is more potential energy. It goes to down means they are releasing energy. Here this point is less potential energy is there. Now less potential energy means they involved in bonding. That is called chemical bond. Here is more energetic now. More energetic means less stable. The atoms are they releasing energy. They involved in bond formation. Here is atoms are there, individual atoms. After they release energy to form molecule. Now this distance is called bond energy. This is bond length. Now here potential energy is 0. Now radius is infinity. Now radius is infinity. Potential energy is 0. Now this point what happened? Potential energy low. They involved in bonding. The atoms are more energetic. They release energy. They are involved in bonding. Means they form molecules. Atoms are combined to form molecule. Understand students? This one. Repulsive forces. Here is repulsive forces, here is plus, here is minus, here is more potential energy. If you go down, potential energy decreases. In height only more potential energy. Here is this point, less potential energy. Less potential energy means they release energy, they involved in bonding. This is the internuclear distance and this one is the potential energy. Now this one is the we explain, plot the graph between potential energy versus internuclear distance. What is this conclusion from graph means? Atoms are more energetic. More energetic means unstable. They release energy. They involved in bonding. Next one. And how many types of bonding is present in the chemical bonding? Already you know, many videos are available. You can use this one also and comment it and subscribe it. Then only we know. Next one is what we can discuss. And in chemical bonding is divided into two types of bonding. One is intermolecular bonding. Next one is interatomic bonding. Write down first interatomic bonding. Interatomic bonding. Atomic bonding. Already inter means in between two atoms. That is interatomic. Next one is intermolecular bonding. Intermolecular bonding. Now write interatomic bonding means this one is the stronger bond. This one is the stronger bonding. Stronger bond. And this one is the weaker bond. This one is a weaker bond. Weaker bond means 20 to 40 kilojoules per mole or kilocalories per mole. Here also 200 to 400 kilojoules per mole means this much amount of energy to require to break the bond. Here also 20 to 40, it is very less compared to this one, it is very less. 20 to 40 means less only na, compared to 200 to 400. Now interatomic bonding, how many types? I am writing interatomic bonding, how many types? There is 3 types of interatomic bonding. One is ionic bond, you know very well this one, ionic bond, ionic bonding or ionic bond. Next one is covalent bond, covalent bond. Next one is metallic bond, metallic bond. Here we can take intermolecular bonding. What are the intermolecular bonding? One is 2 types of bonding na? One is hydrogen bonding, and next one is van der Waals force of attraction or van der Waals bond. Van der Waals force of attraction or van der Waals bond. Attraction only, van der Waals bond, we can remember that one. But this is the weaker bond, this is a stronger bond. Now ionic bond, what is ionic bond? Here I am taking ionic bond example is NaCl, magnesium chloride, MgCl2, magnesium oxide. These are the examples of ionic bond. Now ionic bond, another name is electrovalent bond. Actually in ionic bond, sodium is the which group element? First A group. Chlorine is the 7th group element. That's why this is the metal, this is the non-metal. Actually ionic bonding is electronegative plus electropositive. Here which one is electronegative? Chlorine is electronegative. Electropositive, sodium is electropositive. Either we can take metal plus non-metal, that bonding is ionic bond who are involved. Another name is electrovalent bond. What is electrovalency? Electrovalency means sharing of electrons, that is called covalence. Now here is what in ionic bond who are participate? Metal, non-metal. Otherwise electropositive, because these metals are electropositive, they are easily giving electrons to form cation. That's why electropositive, electronegative. Another name is electrovalent bond. Now here Na plus and Cl minus. Na plus is there, Cl minus is there. What is the ionic bond? Means the electrostatic force of attraction between the oppositely charged ions. That bonding is called ionic bond. What is ionic bond? The one atom is losing electron, one atom losing electron, one atom gaining electron to form cation, anion. If losing electron means cation formed, if gaining electron means anion is formed. There is electrostatic force of attraction between two oppositely charged ions, that is called ionic bond. We can discuss ionic bond later. Next one is, here is covalent bond. What is covalent bond? Means I am taking chlorine. Chlorine belongs to which group? 7th group. How many valency electrons are present? Tell me. How many valency electrons? 7 valency electrons. That's why I am taking 1, 2, 3, 4, 5, 6. One atom is giving one electron, another atom is giving another electron. Now pair of electrons shared by mutually, that is called covalent bond. What is covalent bond? Here I am writing covalent bond means here is one hydrogen atom is giving one electron. In hydrogen atom, how many electrons are present? Hydrogen atom, one electron only present and one proton only present, no neutrons. Okay. Next here I am taking another hydrogen atom. This one hydrogen atom is giving one electron, another hydrogen atom is giving another electron. This pair of electrons shared mutually, they are sharing mutually. This is called covalent bond. Covalent bond is the directional, but ionic bond is the non-directional. You can remember that one. Next one is metallic bonding. Sir, what is metallic bonding? Is a metal, any strip or any metal I am taking, a small piece of metal. In a positively charged metal ions are present. Positively charged metal ions. What is the name positively charged metal ions? That is called kernel. Kernels are present. Positively charged metal ions are called kernel. Now electrons are delocalized. Delocalization means it is not one place it is present. It can be here to hostel to here. They are revolving like you people. And here also electrons are present. Here electron, 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 electron. Here also electron, here also electron, electrons, electron, electron present. Now here is force of attraction. This one nucleus, this one, and this one attracting this one, because the negatively and positively there is a attraction is present. No, not positively. Nucleus, and here nucleus is present, and electron is repulsion, but nucleus. And delocalization of electrons in a kernels, this is called metallic bonding. In metallic bonding, what is present? Positively charged metal ions, that is called kernel, and negatively charged electrons. These electrons are not fixed position, they can be delocalized, total delocalization. That's why this electron here, we can attract this electron here. They have to attract each other to form metallic bonding. Understand, students? What is interatomic bonding? There is three. Now tell me, here is chlorine and chlorine. Chlorine and chlorine, they belongs to 17th group or 7th group. Now here is electronegative atom is electronegative plus electronegative. That bonding is covalent bonding. Electronegative atom, chlorine is electronegative, chlorine also electronegative. Here is metallic bonding means metals, two are electropositive, here also electropositive, here also electropositive. Ionic bonding, covalent bond and metallic bond. Here also electropositive, electronegative. But here is electronegative and electropositive. Understand? Interatomic bonding. Interatomic bonds are the stronger bond. How many types? Ionic bond, covalent bond, metallic bond. Now ionic bond, the electrostatic force of attraction between two oppositely charged ions. Why oppositely charged ions? Sodium is they releasing electrons, they removing electron to try to maintain every atom. Students, every atom must maintain 8 electrons in outermost energy level, that is the octet rule. Another one is they try to maintain noble gas configuration. That's why it's removing one electron, they maintain neon electronic configuration. Chlorine is accepting electron, they maintain argon electronic configuration. That's why this is the bonding involved. There is electrostatic, positive negative means attractive, negative negative means repulsion, positive positive also repulsion. Here one atom is giving one electron, another atom is giving another electron. This pair of electrons are sharing between two atoms. Next one is the metallic bonding. The kernel, positive kernels and electrons are present. Understand, students? We can write it. Next one is the hydrogen bonding. What is hydrogen bonding? Electron, here I am taking AH, here is B, heteroatom. Electron rich heteroatom, electron deficient hydrogen atom, that is called hydrogen bonding. Here is AH is present, this one is called covalent bond. AH is covalent bond. Now this bond is hydrogen bond, HB. Now which one is the stronger bond energy? Bond energy of AH is more compared to bond energy of HB. Why? Because covalent bond is the stronger and hydrogen bond is the weaker. What is hydrogen bond? Electron rich heteroatom. This heteroatom may be, if you take oxygen, nitrogen or chlorine and sulfur, they are involved in hydrogen bonding. Electron rich heteroatom, electron deficient hydrogen atom, that bond formation is called hydrogen bond. Now, how many types of hydrogen bonding? Tell me, how many types of hydrogen bonding? One is intermolecular hydrogen bonding. Intermolecular hydrogen bonding, HB I am writing. Next one is intramolecular hydrogen bonding. Intramolecular hydrogen bonding, HB I am writing here also. We can discuss total explanation when we will discuss hydrogen bonding. Now we can remember what is a hydrogen bond. Electron rich heteroatom. Heteroatom must be electronegative. This one also electronegative, but this one is more electronegative compared to B. Now electron rich heteroatom, electron deficient hydrogen atom, that bond formation is called hydrogen bonding. Again, hydrogen bonding is how many types? Students, intermolecular hydrogen bonding, intramolecular hydrogen bonding. Inter means in between two. This molecule, in between two molecules, that is inter. Intra means within a molecule. For example, orthonitrophenol. Orthonitrophenol, intramolecular hydrogen bonding. If one water molecule, another water molecule, there is intermolecular hydrogen bonding. HF also intermolecular hydrogen bonding. NH3 also intermolecular hydrogen bonding. We can discuss properly next video in hydrogen bonding. Next one, van der Waals force of attraction. Van der Waals force of attraction is the weak force of attraction. Weak force means there are different types of van der Waals force of attractions. One is a dipole-dipole interaction. Dipole-dipole interaction. Dipole-dipole means if you are taking HCl and HCl, this is having dipole, na? Dipole-dipole. Next one is ion-dipole. Ion-dipole. Next one is ion-induced dipole. Ion-induced dipole. Next, dipole-induced dipole. Dipole-induced dipole. Induced dipole. And next one is London dispersion process. London process or London dispersion process. This one we will discuss in states of matter. London dispersion forces. These are the 5 types we can discuss in states of matter, because dipole-dipole means because HCl is the polar molecule. Two polar molecule interaction is dipole-dipole. Ion dipole means, for example, any ion, Na plus ion, HCl. HCl is having dipole. One is polar, another one is non-polar. Next to London dispersion forces. One particular instant, the two are non-polar molecule taking, but particular instant it is behave a polar. It did create dipoles. That is called London dispersion forces. These are the, we discussed in intermolecular hydrogen bonding. This is the interatomic bonding. The chemical bond, interatomic, intermolecular. Please note it. It will be useful for your NEET exam. If you JEE also, but it will be maximum, my video similar to a NEET exam only. In every year in chemical bonding, 3 to 4 questions. What type of questions are? If 2019 they are asking BF3. BF3, what is the hybridization? How many electrons are present surrounding central atom? There is sp2 hybridization. BF3 means 3 bonds, 6 electrons. That is one type of question. In 2022 they are asking He plus 2. He plus, no. He, okay. Hydrogen, for example, bond order now. H2 plus, how many electrons are present? H2 plus means 2 electron. 2 electron means 1 remove, means 1 electron. That type of bond order. Bond order. What is bond order? The number of bonds between two atoms. That is bond order. Bond order formula is there of number of electrons in bonding. We can discuss one by one. Now we can write it: interatomic bonding, intermolecular bonding. Okay, shall I erase it? Okay, fast, write fast. Okay, I will erase it. Next one is a Lewis dot structures. Kozel and Lewis, they represent the atoms. Lewis dot structures. Right. Kozel-Lewis theory. KOSS, Kozel and Lewis theory. Kozel and Lewis theory, they represented electrons around the atoms in dots. They represented in dots, that is called Lewis dot structures. Every atom contain outermost energy level. Atom contain outermost energy level. That is called valence shell. That is called valence shell. What is valence shell? Every atom contain outermost energy level. That outermost energy level is called valence shell. If electrons are present in valence shell, that is called valence electrons. If electrons present in it, that is called valence electrons. Atom contain outermost energy level. That outermost energy level is called valence shell. Now electrons are present in it, that is called valence electrons. Next, what is octet rule? Every atom must possess or must contain, every atom must contain 8 electrons in outermost outermost energy level, outermost energy level, that is called octet rule. What is octet rule? Every atom must contain 8 electrons in outermost energy level, that is called octet rule. The atoms are try to maintain these 8 electrons in outermost energy level. They losing electrons, they sharing electrons, they are gaining electrons, they maintain 8 electrons in outermost energy level, that is called octet rule. These points you have to remember. Atom contain outermost energy level, that is called valency shell. Next, electrons are present in it, that is called valency electrons. Next, every atom must contain 8 electrons in outermost energy level. If atoms are this maintenance of octet rule, they try to losing electrons, they gaining electrons, and they maintain 8 electrons in outermost energy level, that is called octet rule. But some limitations are there, this theory, Coase-Lewis theory. What are the limitations? Because some atoms and some molecules not maintain, the central atom is not maintain octet rule, that octet rule, some molecules. But this Lewis dot structure can be applicable all type of organic molecule, but some limitations. In some molecules like BeCl2, next one is BF3, next one is BeCl2, BF3 and BeCl3. This type of molecules, electrons are surrounding the central atom, electrons present, electrons surrounding on central atom is not octet, because some molecules like BeCl2, if you take BeCl2 na, I am taking BeCl2, here Cl, here also Cl. How many electrons? 1, 2, 3, 4. 4 electron system. This one is incomplete octet. This is the one of the limitation. Incomplete octet. If you taking BF3, in BF3 also, how many electrons? 6 electrons are present. 6 electrons. This one is 1, 2, 3, 4, 5, 6. Now here also 1, 2, 3, 4, 4 electrons. That's why incomplete octet. Here also incomplete octet. Here also incomplete octet. Some molecules like BeCl2, BF3, BeCl3, electrons surrounding on central atom is not octet, not complete octet, not maintain 8 electrons. And here also BeCl2. Next, in some molecules, completed this one. Shall I erase it? Some molecules like BeCl2. Next one. In some molecules like PF5, if like PF5, next one is SF6, next IF7. In this, in PF5, how many electrons surrounding to the central atom? 10 electrons are present. Here is 12 electrons are present, and here IF7 14 electrons are present. This is called super octet. This one is super octet. This central atom is not maintaining octet rule. There is a super octet. In some molecules, the electrons surrounding the central atom not complete, that is incomplete octet. This is super octet. In some molecules like NO and NO2, in this type of molecule, odd electrons are present. Odd electrons are present. These are the limitations of Lewis theory. Pf5, SF6, IF7, this is the super octet, but here is odd electrons are present. Now I am taking another one is the how the representation of Lewis dot structures. If I am taking first A group elements, if you write the Lewis dot structure, hydrogen and next one is lithium. This is the first A group, na? Lithium, one electron only we can represent it. Next one is a second A group element. Second A group elements means beryllium. Beryllium means 2. If you take beryllium or magnesium also, how many electrons? 2 electrons. This is the representation. If you take third A group elements, what are the third A group elements? Boron, aluminium, gallium, indium, thallium. If you take boron, what is the representation? 1, 2, 3. This is the Lewis dot structures atom. Next one is the fourth A group elements. What are the fourth A group elements? Carbon. Carbon means 1, 2, 3, 4. How many valency electrons in carbon? 4 valency electrons, because fourth group. This one, it can be represented dot Lewis dot structure representation of atoms. Next one is if you take fourth after fifth group elements. What are the fifth A group elements? Nitrogen, phosphorus. Nitrogen I am taking, here is 1, 2, 3. Here is 4, 5. It can be represented Lewis dot structure. Lewis dot structures. Next you can take, here is fifth is completed now, 6th A group elements. What are the 6th A group elements? Oxygen, sulfur, selenium, tellurium, polonium. If you take oxygen, how many electrons represented? Here is 1, 2, 3, 4, 5, 6. Next one, 7th group elements. What are the 7th group elements? Fluorine. I am writing fluorine. 1, 2, 3, 4, 5, 6, 7. 7 electrons. Here also chlorine I am writing. Chlorine. 1, 2, 3, 4, 5, 6, 7 electrons. Representation of Lewis dot structure. Next one, 8th group elements. What are the 8th group elements? 18th group elements. I am taking helium. Helium, that is a 2 electron duplet only. This one, hydrogen and hydrogen is 1, but helium is 2 electrons only, duplet. This will be satisfied duplet, not octet. Now I am taking neon. Here I am taking neon. How many electrons? 1, 2, 3, 4, 5, 6, 7, 8. This is the representation of Lewis dot structures. Understand, students? Sir, first A group elements, why are 1? Because only one valency, 1s1. What is the electronic configuration? 1s1. That's why only one electron. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Next you take second A group elements. How to represent the atom? How many valency electron? Lewis dot structure. Beryllium, 2 electrons only, 1 and 2. Here magnesium also 2 only. Next you take third A group elements. Boron, aluminium, gallium, indium, thallium. Boron is also 3 electrons only present. If you take carbon, why are 4? 1, 2, 3, 4, because this is a valency. What is the group number? 4th group. That's why 4 valency electrons. Here also 5th group means 5. Here is 6 means 6 electrons. Here 7 means 7 electrons. It can be represented like this. Atoms are represented. Next one, completed students, first year and second year, third year, fourth year, fifth year. These are the elements we can represented Lewis dot structures. And next one is a octet rule. Some molecules are octet rule, some are not obeying octet rule. What are the first one? I am taking methane. Methane, how many electrons? I am taking first to methane. Methane. Here methane, how many electrons, students? Here is first 1, 2 carbon, 3, 4. 4 electrons are present. Here one of the hydrogen atom. Here also one of the hydrogen atom. Here also one of the hydrogen atom. Here one hydrogen atom. Now how many electrons are present in methane? Methane 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. 8 electrons. 8 electrons means it obey the octet rule. Yes, it obey the octet rule. Octet rule obeying. First one. Next, if you take H2O, if I am taking H2O, water molecule. Now I am taking oxygen first. Oxygen, how many electrons? 1, 2, 3, 4. Here is 5, 6. Here one hydrogen is present. Here one hydrogen is present. Now how many octet are not? 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 electrons. 8 electrons. Yes, it must follow octet rule. It following octet rule. Next one is I am taking third one, NH3 I am taking. Here NH3, how it is represented? Here is how many? 1, 2, 3, 4, 5. First I am writing 5, fifth group. Now I am writing here is hydrogen, here also hydrogen, here also hydrogen. Now how many electrons are present? 1, 2, 3, 4, 5, 6, 7, 8. It is obeying octet rule or not? Yes, obeying octet rule. Yes, it is obeying octet rule. Next to take BeCl2, students, BeCl2. I am taking fourth one is the BeCl2, beryllium chloride. If I am taking beryllium chloride, first write the beryllium. Beryllium belongs to which group? The beryllium group belongs to second group. Second means 2 valency electrons. Now chlorine right here. Chlorine, here one chlorine, 1 means 1, 2, 3, 4, 5, 6. Here also chlorine. Chlorine 1, 2, 3, 4, 5, 6. But central atom, surrounding central atom, how many electrons? How many electrons, students? 1, 2, 3, 4. Here is 1, 2, 3, 4. 4 electrons only. Now 4 electrons only mean students, here is BeCl2 na. BeCl2 means beryllium is the central atom. The surrounding electrons how many? 1, 2, 3, 4. 4 electrons only, incomplete octet. BeCl2 is the incomplete octet. Methane and H2O NH3 is the complete octet. We can take another example. We can write it. Simple electrons I am writing. Here I am taking BF3, beryllium trifluoride, and BF3 boron central atom. How many electrons? 1, 2. Here is 1, 2, 3. In fluorine, how many electrons? Fluorine 1, 2, 3, 4, 5, 6, 7. Here also fluorine take. Here is also fluorine means 1 electron. Here is 1, 2, 3, 4, 5, 6. Total fluorine atom contain 1, 2, 3, 4, 5, 6, 7, 8. But fluorine is the 7th group means 7 valency. Here also write fluorine. Fluorine means 1, 2, 3, 4, 5, 6, 7. Now BF3 contain how many electrons? Total surrounding, this is the central atom. Central atom is boron. 1, 2, 3, 4, 5, 6. 6 electrons only present. This is the incomplete octet. Incomplete octet. BF3 also incomplete octet. One time asking, 2009 time, BF3, what is the hybridization? You know hybridization formula? Z is equal to half valency electrons in boron atom 3, number of monovalent atoms 3, that is equal to 6. 6 by 2, that is 3. sp2 hybridization, trigonal planar, and how many electrons on central atom? 6 electron, incomplete octet. We can take PF5. In take PF5, how many electrons? 10 electrons. This one is the super octet. Super octet. Remember. And phosphorus is the which group? That is the 5th group. Next one is we can take SF6. If you take SF6, how many bonds? 6. 12 electrons are present. That is also super octet. Super octet. We can take IF7. We can take IF7, how many? 14 electrons. In 14 electrons, this one also super octet. Now these are the Lewis dot structure. We can represent it like this. Bit PF5 also 10 electrons. 5 means 5 to the 10 5 bonds are present, 10 electrons, super octet. Some molecules are obeying octet rule, some molecules are not obeying octet rule. In Lewis dot structure we will explain total explanation about how we can write the Lewis dot structure formal charges. Thank you for viewing my videos, and please comment it, share it and subscribe it. Okay, all the best to your preparation.